So today we're going to learn about the OpenGL part 3, okay, which is more on the subdivision gasket, okay. So we move to the subdivision gasket, okay. So this is we're going to develop a more sophisticated three-dimensional example, okay, using the symmetry gasket, which is to introduce the hidden surface removal. Okay, this is the objective for our today lessons. Okay, looks next. Okay, so in order to create the symmetry gasket, what we need to do is, the first one is we need to start with the triangle. So you're going to have your OpenGL ready with the source code, and then try to create the triangle first. And then what you're going to do with the triangle is to divide their midline, and then it's become something like this one, okay. So this one, okay. Okay, so this one, okay, and then you're going to repeat it until 5 subdivision. So it becomes something like this, okay. So it's very nice Sipensky 2D Sipensky gasket, okay. So the gasket is actually a fractal. Say, consider the field area, which is black, and the parameter, the length of all line around the field triangle. So as we continue to subdivide, okay, there's a two main point here. The area goes to the 0, and then the parameter goes to infinity. Okay, if we keep on divide and until we complete our subdivision. Okay. So this is the first program. Okay. Wait. This is, we declare an array. Okay. So an array with 3 times 2 matrix. Okay. So this is the first coordinate. -1, -0.58 for the y. Okay. 1, -0.58, and then at another point is 0.0 and 1.15. Okay. And then you draw one triangle first, okay. So by using the example, you're going to show the first triangle, okay. And then you have the triangle subdivision, okay. This one I will be explaining it soon for the next slide. Okay. So this is example, okay. So we start with the triangle. No. Okay, we start with triangle. So A, B, C. Okay. Okay. So and then we continue with the we draw tetrahedron. Okay. So A, B, C. We call upon the ABC. So we're going to have something like a 3 triangle. Okay. So this is the first one, A, B, C. Then you're going to draw it. Okay. Then, okay, how you going to turn from this triangle into something like this one? Okay. So each line, for example, between A and B, C, and A and C. So you need to divide by 2 in order to get the mid point for the each line. So you have 3 lines you need to divide. So you need to divide between A and B, B and C, and A and C. So since you need to have X and Y function, so you need to divide between mid 1 and mid 2. You name it as a mid 1 and mid 2. So mid 1 is the X for the result for divide by 2. Nak mana? Sorote. Tak apa, Zayn ambil kat sini je. Okay, once you get it, but somehow it's still not quite in terms of how we code. The situation is not quite good. It's quite not been defined. So we define it by using 4 function. Okay, it's just the same. So for j equal to 0 and j equal to 1. Okay, so it's repeat for using the for loop. Okay, so 0 is we fix at the location x equal to 0, but only the y is we change it. Okay. Okay, next we do it for the second loop for the A and C, and then B and C. Okay, so this one is for the mid one. There's now mid 0 and J. Okay, this and then the one is mid 0. So the other one is mid 2J. Okay, so we have 3 of them. Okay, okay, you need to divide it soon. You need to create the tetrahedron. So you have a function here, divide tetra. Okay. Macam mana? Nah. Okay, so this is the function of divide tetra. Okay, so you get an A. Okay, you repeat with M0 and then mid 1 and M minus 1, and then you repeat it until you have for each of the triangle that you're going to develop. Okay, so divide by 1 in order to enter the loop again. Okay, so this is the divide tetra function. So they declare the mid function 3 3. Okay, since you need to have 3 midpoint. Okay, so you compute the 6 midpoint. Okay, by the point for each of this line you generate 2 mid 2 points. Okay, x and y. So you have the coordinates of the each 3 of them, and then you need to create the tetrahedron. Okay, so it becomes something like this. Okay, never mind, we will see the example using the OpenGL soon, using the source code, so we're going to see what is going to happen. Okay, and then this is the display function. Okay, so GL display, GL clear, then begin the triangles to divide the triangle. Okay, call the divide triangle function. Okay, and then this function my init is this is where you're going to actually no, tak boleh. Ni je, sini bawah boleh. Okay, this is my init function. This is where our display is going through. Okay, so this one is main function. Why is n equal to 4? Okay, since you need, because you were going to actually to make it recursive until 4 times. Okay, so by GL begin and GNN at the display callback rather than in the function triangle, and using GL triangles rather than GL begin, we call GL begin and GNN only once for the entire cascade and once for each triangle. So you need to declare this only one. Okay, so we can easily make the program 3-dimensional using the GL float v3 and 3. Okay, and then GL vertex 3f and then GL auto. Okay, but that would not be very interesting. Instead we can start with tetrahedron. Okay, okay, bye bye. Okay, so next one, for the 3D gasket. Okay, what you going to do is somehow you have the first triangle and then you divide it. Okay, what you're going to do is you need to have 4 of them. Okay, this is 4 faces. Okay, so we can have something like this one. So and then after 5 iteration you will get something like this. Okay, so this is the first, and then this is divide triangle function. It's almost look the same, but we just create it for the 3D environment, for 3D gasket. Okay, and then this is the tetrahedron code. If you look for the first 2D symmetry gasket, you will see that we only have a divide triangle only once. Where? Let's go back to the paper slide. Only once. Okay, so right now we have 4. 1, 2, 3, 4 of them. Okay, so we need to have 4 because we have 4 faces. Okay, like a pyramid. But if you actually run it for the first time for the tetrahedron, you can see that there's a quite different between this one, but you want to have this. You can see that this green simplicity tetrahedrons actually appear in front of the screen. So actually it's at the back of the screen. Okay, so actually you want to do this, so you can find this quite differences between these two. Okay, so that's why you need to have to use the hidden surface remover. But what you're going to do is just some simple code that which is available in OpenGL. Okay, so OpenGL use the hidden surface method called the Z buffer algorithm that save depth information as objects are rendered, so that only the front objects appear in the image. For the more information, of course, you can Google it through the information. I will not tell you more about the Z hidden surface method because there has a lot of literature about it. So we are using the Z buffer. You can put it into the GL init display mode. Okay, GL single, GL RGB, GLUT RGB, and GLUT depth. Put it into the GLUT init display mode, and then put the GL enable GL depth test. Okay, and then clear it in the display callback. Okay, so need to put all these three commands into the main function and also the function that has these things. So in this example, we actually have a division of for the east surface of the object. So we could also divide the volume using the same midpoint. The midpoint define the four smaller tetrahedron, one for the east vertex, so we can call it tetrahedron. We will not call it as a triangle here. Okay, keeping only that this tetrahedron remove a volume in the middle of the. You see the depth for codes. This is the what we is appear when you actually subdivide. Okay. So so this is the example of Sipensky gasket. You will see this actually in Ulen. Okay, where I have put all the materials inside the Ulen. So you're going to have a look and then check it for yourself, and then try your best to understand which command and so on. Okay. So that's it. Let's go on. We're going to have a look on the source code. Okay, run. Okay, Zayn. No, Zayn, no.
Every key.
Okay, so we have this one. Okay, so this is the quite nice Sipensky gasket. Okay, so what's let's say we put it as 4. Okay, iteration is equal to 4. Okay, we change it into 4. Okay, it's become something like this. Okay, so here you are, the 3D Sipensky gasket. Okay, so the objective here is to actually become familiar with the OpenGL in order to by using the simple GL vertex. Okay, for example this white triangle. Okay, and then you create it by using your own skill. Okay, to create your any 3D object. Okay. But of course, you can also actually have a 3D object from the external sources. For example, if you are using you have created 3D object using Maya Cinema 4D, and then you can export it into OpenGL by using some few portion of codes to call the objects. Okay, and then map it into the OpenGL. And of course, with the technology has become tremendously increased for the people to use game engine to create and develop their own simulation or games. Okay, you can drag and drop the 3D object and then display it in the simulation. Okay, so this is the tetra function. Okay. So this is where this color so on. You can change the color here. Okay. This GL color has been defined here. Okay. RGB, remember? So red, green, and blue. Okay. The other one is for white. Okay. And then this is for the divide tetra. Okay. You have 6 midpoint that you're going to compute. Okay. So and then you create the 4 tetrahedron by the subdivision. Okay. So that's it for today. So soon, for the next chapter, we're going to have a look on the input and interaction. So for my student, make sure you learn properly and then ask in the WhatsApp groups, and then try your best to complete the assignment has been given in the ULearn. So thank you for today and have a nice day.